All right, chemical reactions, unit 4. At least it's only 1 this time. All right. Remember that when we classify matter, we can classify matter as either mixtures. Mixtures then when we talk about mixtures, they're combined physically. It's a physical change when they combine as opposed to a chemical change. We can use physical changes then to separate mixtures, such as decanting, chromatography, distilling. Like there's lots of ways that we can change these. We have 2 categories within there, which are homogeneous mixtures, visibly indistinguishable parts, and heterogeneous, where they tend to be distinguishable. Now, where that gets a little shady is when you get into colloids. Okay. Fog looks like fog throughout. Jello looks like jello throughout. Okay. But most people consider that a heterogeneous mixture. Pure substances then have a constant composition. So water is always 1 oxygen and 2 hydrogens every time. You change that ratio, you got something different. They are combined, the elements within there are combined chemically, and you have to use a chemical change to be able to break them apart. Elements then are the simplest substances, and you can't decompose those into anything simpler.
Like H.
Like H, yeah. All right, here's just kind of a breakdown of these. We've got matter. And is it variable in composition? Yes, then that means it's a mixture. Can you distinguish those parts? Yes, it's heterogeneous. And the 2 categories here are colloids and suspensions. So suspensions and colloids. Example of a suspension would be like sand and water. Colloid would be like jello. Homogeneous then is also known as a solution. It has 2 components of that solution. What are the components of the solution?
Solute and solvent.
Solute and solvent, good. The solute is what's mixed into the solvent. All right. Then we have where the composition is not variable. And that's going to be your pure substances. If it contains more than 1 type of atom, that's going to be your compound. Okay. And compounds can either be covalent, in which their smallest part is going to be the smallest part of a covalent compound. Molecule. And it could also be ionic, and they usually call the smallest part of that a formula unit. I don't like to abbreviate that one. No, I got it. All right. If they don't have various types of atoms, if it's only 1 type of atom, then it's an element. And those are your atoms. Remember that we can have within this those Brinkelhoffs, so they can still be in the form of a compound. In a way, they're just called diatomic molecules. Okay. All right, physical change then. A physical change, come on, move for me. There we go. Physical change is where we have several types of physical reactions that can take place. Phase changes are physical changes all day, every day. Do not get that one wrong. They will try to trip you up because you're like, well, ice and water are different. No, the only difference in them is what? Right. It's how far those are, the attractions between them. So ice, you're going to have very strong intermolecular forces. Liquid, you're going to have weaker, and gas, if it's an ideal gas, doesn't have any at all. It's the strengthening of those IMFs that changes these phases, but you have not changed the makeup of that material in any way, shape, or form. It's still, if you're talking about water, it's still H2O. Okay. As temperature increases, your molecular motion will increase. As temperature decreases, your molecular interactions, also known as IMFs, will increase. That make sense? All right. These are your phase changes. Gas to a solid is called deposition. An example of that would be like frost that forms on your windshield overnight. Sublimation, then, an example of sublimation would be dry ice. The CO2 in a solid form goes right to a gas. There's no intermediate stage. Solid to a liquid, we call that melting. Sometimes that's called fusion. And we're going to get into that when we get into some thermochem, because we have the heat of fusion that we talk about. Okay. Actually, I think fusion goes this way, doesn't it? I'm confusing myself now. Freezing, just use melting and freezing. And then vaporization goes this way, condensation is this way. There's two ways that you can vaporize things. What are they? Oh, that will happen. What's that called if you do it rapidly? If you vaporize something rapidly, what happens? What is it? What does it do? Boiling, yeah. Okay. And if it's a much slower process, this happens at the base, right? It changes to a gas down here. The gas is less dense than the material it's in. It floats to the top and escapes out and is gas. What about if this is at room temperature and it's escaping out as a gas? What is that called? Evaporation. But this happens from the surface. This happens from the base. And you've seen the bubbles form at the bottom, then they float to the top and move up, right? So that's the difference between these. All of these are what kind of changes? Physical changes and phase changes. And they both start with good. Physical changes or phase changes. All right. Other examples of physical changes include separations of mixtures. We talked about that as far as chromatography. We talked about filtration. We've talked about changes in boiling points and how they use that for like the fractal distillation in refineries, right? Didn't I talk to you guys about refineries and how those work? Okay. Filtration is based on particle size. You can get different types of filters. Even at your house, you probably have like a colander and a strainer. And the colander has holes that are like this, and the strainer has holes that are like this. They're going to allow things through the colander that you wouldn't allow through here. Okay. So, other types of physical changes, then deformation of the substance. You can cut, you can tear, you can dent, you can stretch. We talked about malleability in terms of metals. We've talked about ductility in terms of metals, where they stretch it out into thin wires. Solutions then is another type of physical change. When you take water and you put sugar down in it, okay, and you make your Kool-Aid, we could evaporate that liquid off and we would be left with that powder again. Okay, these are just physically changed. They're not going through any kind of chemical change. Key feature of a physical change is that the atoms are not rearranged. Physical properties then are going to include shape, color, texture, flexibility, density, mass. Physical changes are usually reversible. Okay. You could even take like a piece of paper and tear it. Okay. We could take that paper and soak it in water and all of it back in water and reform it into paper and let it dry. Yeah. Yep. So you talk about like paper, for example. That's an example of how you could do that. I mean, it would make a mess, and it might not be as pretty as what you started out with because you don't have it refined like some of the paper pulp manufacturers. But yeah, you can actually make your own paper at home. There are people that make their own paper. You know, if we run out of toilet paper again.
I've seen videos of that.
Well, some people do it. Yeah. But some people do it for like art. Like it's beautiful. Some of the papers that they make are just absolutely beautiful. Let me see if I can.
I don't like it. It's just like.
Yeah, in an artistic kind of sense, it ends up being kind of pretty. I mean, this is a lot of times what it'll look like, and then sometimes they'll embed like shapes and different things in it. It's a rough. It's much rougher than what you're used to, but you can embed stuff in there and make it. It ends up being kind of pretty in an artistic kind of way.
A singular one is pretty, but if you put them in like a notebook,
so, I mean, it ends up being kind of rough, but like I said, you're not some paper mill out there who has the chemicals and stuff to do that, but you can literally make your own papers and stuff. People do it. So anyway, I digress. Moving back. All right. Evidence of chemical change. Now, we have talked about these before, and we have examples here. Producing a precipitate. You are creating a new phase, such as solids, in that test tube. Color change. Now, this isn't always the case. It may be a dye that you've added in, or it may be you've taken a crayon or a marker or something and you've colored it. That's not a change in this. But think about like an egg, right? You're frying an egg white. If you're doing the egg white, it starts out as translucent, like you can see through that. And then you fry the egg white and it becomes just pure white, So that's definitely a color change. Light being produced, like when you light a match. Change in temperature, like when you light a match. Sound, like when something explodes. Evolution of gas. We talked about the CO2 being, when we react that with the baking soda and the vinegar together, it's going to produce CO2, so a gas being produced. You are always forming a new substance, and that new substance is going to have new properties. My quintessential example of this is taking hydrogen gas, oxygen gas, and making water. Okay? This is very flammable. Think of the Hindenburg. It go boom. Okay. Oxygen. supports combustion. We have to have this present in order for a fire to exist. Remember your fire triangle, the 3 parts of your fire triangle. Oxygen is one of them. Okay. In some cases, like with the booster rockets on a lot of the spaceships, this is your fuel. You get some oxygen in there and you're going to create heat and a lot of force. They go whoosh. Okay. So we've got these things. They're gases at room temperature. We go through a phase change. We create water. What's the primary thing that they do to get rid of fire? It was the primary thing that they use? Water. That's why there's fire hydrants that are filled with water. Okay. So very distinctive change in properties here. This is a liquid at room temperature. Very difficult oftentimes to reverse. You're not getting that egg white back out of that egg once you fry it. Okay. All right. These are your different types of reactions. This is called a synthesis reaction or a composition. We are taking 2 things and we're making them into one. I liken this to what thing that you go through sometimes in your life? Marriage. Okay, so this is like marriage. You have 2 people, you become a couple. And then this would be like what? Divorce. Okay, you got a couple and you're breaking them apart. Here, what is happening? Yep. Somebody came in and B is by themselves now. Okay. A took their place. This is just messed up, y'all. Okay. A and C are swapping spots. This is called a double replacement reaction. And then this is a combustion of a hydrocarbon. So this is a hydrocarbon. You've got hydrogen, you've got carbon. These X and Y can change their amounts depending on what substance you're starting with. Ethanol, methane, octane, all of those anes. There's a bunch of them, and that will change, but it's going to have oxygen here. Sometimes this has oxygen as part of it too, like ethanol. Okay. So that's why they say with or without O. It's going to have this O though, because this is what combustion is. You are burning something in the presence of oxygen. It's your Fryer triangle again. The 2 things that is going to produce then are CO2 and H2O. And then that's with this being a complete combustion. You can also have incomplete combustion where you're going to form carbon monoxide. And that is why you need to make sure that you have your garage doors open. And you need to make sure that your furnaces are venting properly. Because the stuff that you're burning in your house is going to go through incomplete combustion. And you will have CO emitted. And carbon monoxide is very deadly. It is odorless and colorless, so you have no idea that it's there until you have problems. And that's why they recommend that people have carbon monoxide detectors in their houses. All right. Double ionic replacement is also going to include acid-base neutralization and precipitation reactions. Okay, if we take hydrochloric acid and react sodium hydroxide for them with that, what are we going to form?
Water and salt.
What kind of salt? NaCl. Remember, all ionic substances are called salts. So you can't just say salt and expect people to know that it's NaCl. This is called a neutralization reaction because you're taking an acid and you're taking a base and you're forming a neutral salt. And we're going to get into why these are neutral later on. And you're forming water, which is also neutral. So this is a neutralization reaction.
So when you combine an acid and a base and get a neutral and water, that means it's a neutralization?
Yep, and this is a neutral salt. And we're going to talk about the difference between an acid salt, a basic salt, and a neutral salt. I think it's unit 8 that we get into. So you're not expected to know that at this point. I'm just bringing it up to kind of foreshadow where we're going. All of these also can be considered redox reactions. Redox reactions are reduction oxidation reactions, except for the double ionic replacement reactions. And we're going to talk about more about these redox reactions later on. Fun times with oxidation numbers. Okay. All right. I do. Types of matter. Is this an element, a compound, mixture? What kind of element? It's one of your diatomics. Yep. Okay. They're both the same substance. State of matter here. Yeah, I would say either liquid or gas. Probably a gas, I'm guessing, because most of your diatomics are gases. All right, what about this guy? Is this the same as this? No. So this is a mixture. This is a diatomic element. This is a compound here. But when they're in the same container, it's going to be considered a mixture. And again, I guess I would call this a gas. A gas or a liquid. Probably a gas. How about this guy? Mixture of element and compound. And again, I would say that this is a gas. What is this? Compound. And this is a gas again. I would call this a solid. Element or mixture? Element. Good. And what is this? Mixture. And again, I would say this is a gas. All right. Chemical or physical change. Over time, solutions of iodine and water gradually lose color as the iodine evaporates. There's your key word right there. Physical change. This is a phase change. Good. When a drop of acid landed on my pants, a small hole appeared. Chemical. Pissed. When a solution of lead nitrate and a solution of sodium chloride are mixed, a solid precipitate forms. Chemical, right. At Halloween, many people use dry ice in their decorations. It sublimes into a gas and creates a foggy effect. Phase change, physical change, right. Okay. So tomorrow we are getting into net ionic equations. Tonight you have 4-1 to work on for homework.